here are some integral rules that you should be aware of. Suppose you have a function f of x looking something like this. Then the integral from a to b, so from a to b, so the integral from a to b, which is this area here, from a to b here. So this here is this area here, and then if you get this area plus from B to C, so plus from B to C, that's this area here. Okay, if you get this area plus this area, then it will give you this area here. Okay, so this area here is from A to C. So this area here is this whole A, from A to C. That's this whole area here. So it's kind of obvious. So hang on. So this area here is from A to B. So if you get this area plus from B to C, so plus from B to C here. So if you get this area plus this area here, then that's the same as from A to C. So that's the same as from A to C. It's kind of obvious. I hope you can accept that. Okay. So the another one that you should be aware of. Suppose you have a function f of x looking something like this. Now, if you have, let's say if you have k f of x. So when you have this k, it gives you the impression that you're stretching it by a factor of k. So in our case, we chose k to be 3. Well, if that's the case, then let's say this here has a height of 2. So if you have a k being a 3, that means it gives you the effect that you are stretching everything by a factor of 3. So 2 times 3 would be 6. So this here will get stretched up to 6. Okay, so if you have this here to be, let's imagine it to be 0.5, then if you have a k value of 3, it means you stretch everything by a factor of 3. Then this height here will be 1.5. So it stretches from here to here it stretches it up by a factor of 3. So if you have, let's say, this here to be 4, then if k is 3, then you stretch it by a factor of 3. So that would then take you to 12. So k f of x gives you the effect that you are stretching everything out by a factor of k. Well, if that's the case, if k is a constant, then you can actually take it out here. So what this here is saying is that the area underneath k f of x, so that's this bit here, k f of x, so that's this whole area here. Hang on. So that's this whole area here, the whole area here. So it's saying that the integral of k f of x here from a to b, that's the same as you just taking the k out and then concentrate on working out the area of f of x. So the area of f of x is this area here. Okay, so it's saying concentrate on working out working out this area here, the normal f of x, and then whatever the answer is, times it by k. That will be the same as you working out the area of this whole thing here. Okay, I hope you can see that. Another thing, don't visualize k f of x to be like this. Hang on. Don't visualize k f of x to look something like this, because it's not the case here. Okay, if you visualize it like this, which is wrong, don't visualize it like this. If you visualize k f of x to be something like this, then this here wouldn't make sense. Okay, because well, what's happening here is you adding everything by a factor of k. Everything is being added by a factor of k. This here is not the same as this. You see, you should visualize k f of x to be something like this. Everything's being stretched by a factor of k, but don't visualize k f of x to look something like this, because if you do, then this here will just confuse you. I hope I haven't confused you, but don't visualize k f of x to look something like this. Okay, it should k f of x should look something like this. If you visualize k f of x to look something like this, then this here will make sense. Okay.